Hi everyone, this is Rebecca at Betterbred, and today I am doing a video on the need for genetic diversity. The goal of this presentation is to introduce the measurements OI and AGR and demonstrate their use in selecting for breed-wide genetic diversity. But first, let's review. In the last presentation, we learned about the uses and limitations of IR, which is also internal relatedness. In particular, we learned that IR helps us determine how inbred a dog may be, but it does not tell us how typical or atypical that dog is for its population. Meaning, does it have a lot of bottlenecked genetics or genetics that are different from the bottlenecked? So we introduced the concept of bottlenecked and depleted population. Let's go over those now. A genetically bottlenecked population. In the last presentation, we discussed that several breeds thus far run at UC Davis have been found to be bottlenecked. So what's the definition of a bottleneck? It's a severe reduction in the alleles in a population, meaning a reduction in the variation of genes the population has. Genetic depletion of a population leads to loss of viability of that population. Viability? What do we mean by that? It's the ability of a population to remain and avoid extinction. When breeds lose too much of their natural genetics, there are more and more health problems. Reproduction becomes less successful, and there tends to be more immune system dysfunction. When species lose too much diversity, they eventually become extinct. Now, in terms of genetically bottlenecked populations, there's different types. One very common type is the founder effect. What is the founder effect? It's loss of genetic variation due to use of few individuals in the founding of a population. Many breeds have the founder effect. It's caused by events like world wars, few imports that start a breed, popular sires, things like that. So what do we do in these populations? We need to retain the diversity that remains. Some other countries may have more or different diversity, so importing can be a potential benefit. The idea being that it will dilute the bottleneck genetics and therefore dilute any complex diseases that have been set within that bottlenecked breed. If all else fails, in extreme cases, an outcross to a similar breed may be warranted. And once you do that outcross, you need to make sure that you test the outcross offspring in order to maintain that genetic infusion, because believe it or not, it's like a drop of water into a bucket. If you don't continue to test that genetics, it'll disperse into the population and be lost very quickly. So continuing on with bottleneck populations, some breeds have many genes found in their entire population. However, in some breeds, the majority of the dogs carry the same common alleles or variants of genes. So they'll have lots of different types of genes or alleles found in the population, but the majority of dogs only have a select few. The alleles carried by the majority in the population are called effective alleles. Now, when we say depleted populations, what do we mean by that? This is a term we use to describe certain breeds that have been found to be in worse condition, that they have very few effective alleles, but they also have very few overall number of alleles found in their population. So, for example, the majority of the alleles found will be a certain type of allele, but then there is also only maybe 6 variations in that gene found. Bottlenecked populations include Dobermans, Shiloh Shepherds, Standard Poodles. Really, as we've said before, the majority of breeds tested are bottlenecked. So now what? Whether your breed is bottlenecked or not, we want to increase the number of effective alleles in the population or maintain them in order to increase a breed's long-term viability. Maintaining diversity. What do we mean by that? For many years, captive populations have been managed in zoos by making an effort to reduce inbreeding and maintain genetic diversity. Maintaining species-wide genetic diversity is the way species remain viable in captivity long-term. It's also used in some herd management, like bisons. Purebred dogs, though, they're not zoo animals, and we know that. However, their breeding is certainly managed and controlled. We don't allow them to pick their mates, and therefore it's very easy for even diverse breeds to lose their diversity rapidly. Say if everybody wants to use the same stud who won a very big specialty, it's very easy for breeds to become bottlenecked quickly. To maintain a species long-term, zoo management programs use complex calculations to select mates with maximum genetic diversity together while maintaining low inbreeding. Better Bred uses the same idea in a calculation called AGR, in addition to IR. AGR stands for Average Genetic Relatedness. All right, so average genetic relatedness. How related your dog is to all the dogs in the same breed in Better Bred. Average genetic relatedness is based on calculations from a paper written in 2002 by Zhenliang Wang. It also sometimes is referred to as mean kinships in genetics. A dog's AGR is based on how likely it will share genes with every other dog in the Better Bred database. Each STR and STR frequency is used in the calculation. So what do the numbers mean? A dog with a low AGR is unrelated to the rest of the breed on Better Bred. A high AGR indicates that the dog is highly related to much of the population on Better Bred. I'm going to pause here also and note that when you look at different breeds, you cannot compare any of these numbers among breeds. So you can't look at Akitas and their AGR and look at, say, Doberman Pinschers and their AGR and compare those two breeds. All these measurements, IR, OI, AGR, they are all dependent on your specific breed. You can't compare them within breeds or outside of breeds. Okay, continuing average genetic relatedness, the benefits of AGR. It helps you determine which dogs in the Better Bred database are least related to your own. It's very similar to what zoo management programs use in order to maintain captive species viability. Many papers are dedicated to the maintenance of captive breeds and their management. This technique is one of the best methods tested out there. So select for lower than breed average AGR while selecting for type, temperament, drive, etc., like you normally would for your breedings. We are definitely not advocating for considering genetics above all other aspects of dogs. So what's the limitation of AGR? Because the calculation is based on your dog compared to all the dogs in your breed on Better Bred, AGR is dependent on the dogs in the database and therefore subject to change as more dogs are added. This adds relevance to the next calculation we'll discuss, which is outlier index or OI. Currently, also, we cannot calculate AGR for litters, although we are hoping that we can do it in the future. Moving on to outlier index. Outlier index, how genetically significant a dog is for its breed. So remember how we discussed how IR does not tell you whether a dog is atypical or typical, or if it has common bottleneck genetics or non-bottleneck genetics. This is the measurement that we look at to determine that. At the start of Better Bred, when standard poodles were run, which is why there's a picture of standard poodles, Natalie developed another tool to aid in the genetic analysis of each dog and potential litter. It was created to help demonstrate how significant a dog is for its breed. Because AGR relies on dogs currently listed in Better Bred, OI is useful for populations in which not all the tested dogs in the population are in the database. This measurement also has a patent pending. The outlier index, termed OI, weighs rare and neutral genes. It gives breeders a measurement to help select away from bottlenecks. It uses breed-wide allele frequencies gathered at UC Davis. The outlier index tells you how unusual a dog is in reference to the population tested at UC Davis. The higher the OI, the more atypical or genetics that are not bottleneck genes. The lower the OI, the more typical or the more bottleneck genetics. And if you see over here, when you run test breedings on Better Bred, in your litter summary, you get these ranges in OI, so you can see where your predicted puppies would fall in terms of their OI scores. So what's the benefit of OI? An OI range can be calculated for litters, which is important when planning your breedings. It does not rely on large numbers in the Better Bred system. It's based on the allele frequencies at UC Davis. So what's the limitation? It's not necessarily a limitation, but it will change over time as more dogs are added to the tested population. And as we breed and select for higher OIs in our puppies, and we will be redistributing the genetics, the OI for our breed will change and the OI for our dogs will change. And that's really what our goal is. We want to redistribute the genetics that we have retained in our breeds over time. So it will be a measurement that will change with time. However, again, UC Davis attempts to run large and diverse samples prior to moving to phase 3. So prior to moving a breed to being finished, UC Davis attempts to get a very large sample of the breed before they release it, and therefore OI shouldn't be largely affected once they've gone to phase 3. Okay, so when I said that OI or AGR cannot be run for a litter, it's important to therefore look at OI in your test breedings because OI and AGR are inversely correlated. So you can use OI to help select for low AGR in your keeper puppies. So look at your litter's OI range to breed for a lower AGR. Okay, so in conclusion, IR in conjunction to OI and AGR can help you breed less inbred dogs and preserve diversity in your breed. In upcoming presentations, we will discuss how to use Better Bred. There will be presentations in groups and to demonstrate its use. So if you check out Facebook and see if there is a genetic diversity group particular for your breed, join up, and we will be running test breedings and answering questions on how to use Better Bred and all these measurements. As well as a new member joins, they will receive a website walkthrough video. Have any questions? Please email Rebecca at betterbred.com.